Good morning, viewers. This is Kasturi Day. Today I'm back with the measurement and this first chapter. Okay. So this is the physics chapter, first chapter according to ICSE syllabus, class 8. Class 9. Okay. So I'll be starting with the Vernier calipers. Okay. I'll be discussing the Vernier calipers. So how to measure a length with the Vernier calipers. Okay. So the picture you can see is the Vernier caliper scale. Okay. This has the instrument. It has two scales. One, this is the main scale. You can see the arrow which is pointing out the main scale, that is fixed scale. Okay. The broken lines, this indicates that the scale is long. So in the picture, the whole scale is not coming. So that's why it is discontinued in between. So it looks like this one. Okay. This is the main scale, which has a graduations. Okay. And there is another sliding scale which is attached to the main scale, that is the Vernier scale, that is movable. It can move. Okay. And this movable the scale is attached to a movable jaw. Okay. These two, the bigger jaws, one is fixed jaw, another is the movable jaw. These two bigger jaws, these are used to measure the external dimension of a substance, and the upper two, these two are smaller jaws. These jaws are used for internal dimension of a substance. Okay. So, and this is a clamping screw, which is used to move the Vernier scale on the main scale. Okay. Next, we come to how to I'll discuss this measurement of the length, which is by using the Vernier scale. Okay. The instruments for measuring the length of the measuring the lengths can be used by what are the instruments which are used for measuring the lengths? These are rulers, then calipers, Vernier calipers, and screw gauge. This is not calipers, this is calipers. Okay. Please add a C to it. So the instrument for measuring the lengths, these are ruler, which we use in our daily life, like for measuring anything, then rulers, then calipers, Vernier calipers, and screw gauge. In the 17th century, Vernier, okay, he was a French mathematician. He devised a method for measuring the length. And after his name, this instrument is named as Vernier calipers. Okay. He measured the length correctly up to 0.1 millimeter. Okay. He measured the length up to 0.1 millimeter. In this instrument, there are two scales. One is the main scale, I told you, which is fixed, and it has millimeter graduations. The graduations, which are marked on the main scale, that are in millimeters. Okay. And Vernier scale, that is sliding on the main scale. Okay. Now, what are this? The principle of the Vernier calipers. Principle is the length of n division of the Vernier scale is equal to length of n minus 1 division of the main scale. Okay. Like, for example, if the Vernier scale has 10 divisions, that will be equal to the main scale division will be n minus 1, that is 10 minus 1, that will be 9 division of the main scale. That means if the Vernier scale has 10 divisions, the main scale will read 9 divisions. Okay, so 10 of Vernier scale is equal to 9 of main scales. Or you can say if the Vernier scale has 20 divisions, then the Vernier scale will, the Vernier scale has 20 divisions, then the main scale will read n minus 1, that is 20 minus 1, that will be equal to 19 division of the main scale. Okay, that is the principle of the Vernier calipers. Now, Vernier constant. Vernier constant is equal to value of one main scale division, that is S, that is minus the value of one Vernier scale division. Vernier constant is equal to value of one main scale division minus the value of one vernier scale division. Okay, that is, if the main scale division is treated, the value of the main scale division is treated as S, and the value of one vernier scale is treated as V, then we can say it will be vernier constant will be equal to S minus V. Okay, now the least count of the vernier is equal to least distance which can be measured accurately by it. Okay, the least count of vernier is the least distance, the minimum distance which can be measured accurately by the vernier. Okay, and that is equal to what? Vernier constant. And that is equal to what? That is equal to value of one main scale division by total number of divisions on the vernier. Value of one main scale division. Okay, and that will be divided by the total number of divisions on the vernier. Okay, then the vernier calipers is equal to, you can say the vernier calipers, it is also called as slide calipers. Okay, now it is used to measure the length of a rod, depth of a small beaker, diameter of a sphere, the internal and external diameters of a hollow cylinder, etc. So vernier calipers is used to measure what? The length of a rod, the depth of a small beaker, the diameter of a sphere, the internal and external diameters of the hollow cylinder. See, for the length of the rod is attached in the lower jaw, the bigger jaw. Okay, and is fixed between the bigger jaws, and the measurement is taken. Depth of the small beaker, here the internal diameter is taken. How much deep is the small beaker? So the smaller jaw is used. Okay, then again for the diameter of the sphere, the external jaw is used. For the internal and external diameters, internal diameter of the hollow cylinder, the upper jaw, that is the smaller jaw used, and external diameter, the hollow jaw is used. Okay, so in this way, the jaws are used for measuring the hollow, for measuring the length of the different substances. Okay, next is zero error. This is an important thing which one should know for using the vernier, because if there is a zero error, the length will become faulty. So first, what is zero error? First, we should know what is zero error. Okay, it is equal to the length between the zero mark of the main scale and the zero mark of the vernier. Length between the zero mark of the main scale and zero mark of the vernier. This is necessary. Why this is necessary? To get a correct measurement from the instrument. Sometimes what happens, as we know that there are two scales attached to in a single instrument, what happens? The main scale 0 may not coincide with the vernier scale 0. What is that? See in this picture, this is the main scale 0. Okay, this is the main scale. I told you the broader scale is the main scale. So this is the main scale 0. And this one, the sliding scale, the vernier scale 0 is this one. So when the jaws are attached together, okay, when the jaws are close to, when it is not in use, when the vernier caliper instrument is not in use, then we will keep both the jaws close together. Okay, so at that time, if the 0 of the main scale does not coincide with the 0 or with the 0 of the vernier, then what happens? The instrument will have 0 error. Okay, the instrument will have 0 error, and the distance between the 0 of the main scale at that time, that means when the 0 is not coinciding with the 0 of the vernier, that time the distance between the 0 of the main scale and the vernier 0 of the vernier scale, that gives the 0 error, value of the 0 error. So what do we do to make the correct, measurement of this zero error? How do we use the zero error to make to take the correct measurement? Okay. So for that, we should know that there are two kinds of zero error. One is positive zero error, another is negative zero error. Now for positive zero error, when two jaws are brought together, if the zero mark of the vernier is on the right hand side of the zero mark of the main scale, when the two jaws are brought together, when it is not in use, when the caliper is not in use, what do? I told you the two jaws are brought together. At that time, if the zero mark of the vernier scale is on the right hand side of the zero mark of the main scale, then the zero is said to be positive. See, for the experience, this is the positive zero error. See, this is the zero of the main scale and this is the zero of the vernier scale. Now, when the two jaws, and suppose this is the jaws, upper jaw and the lower jaw, when the two jaws are in contact, at that time, the zero of the vernier scale is on the right hand side of the zero of the main scale. Then the instrument has positive zero error. Okay. Then what do we do? This is equal to, this positive zero error is equal to the number of vernier division that is coinciding with any division of the main scale. The number of vernier division is, that is coinciding with any division of the main scale multiplied by the least count of the vernier. Okay, multiplied by the least count of the vernier. So, see, any division which is coinciding, any division of the vernier scale that is coinciding with the main scale, this is 3 which is coinciding. Here in this picture, see, 3 mark of the vernier scale is coinciding with the main scale. This is also 3 mark which is coinciding with the main scale. So what is to be done? Then positive zero error will be plus x, that is, as it is positive, so plus x is what is the division which is coinciding. Here it is 3. So 3 into the least count. And what is that least count? Least count will be equal to the least distance which can be measured accurately by it. That is called the Vernier constant. And what is Vernier constant? Value of one main scale division minus value of one vernier scale division. Okay. So see, this positive zero error will be plus x into LC, that is least count. So for example, to find this error, the division of the vernier scale is noted that is coinciding with the division of the main scale. Then the number of the vernier division is multiplied by the least count of the vernier, which gives the zero error. For example, if the least count is 0.01 centimeter, then the 6th division of the vernier scale coincide with the main scale. Okay, so if the least count is 0.01 centimeter and the 6th division of the vernier scale is coinciding, the zero error will be plus 6, okay, into the least count. Least count is 0.01 centimeter. So the positive zero error will be 0.06 centimeter. Okay, hope I have understood it. Next, I'm going to negative zero error. Now what happens when the two jaws are in contact? Then the zero mark of the vernier scale is on the left hand side of the zero mark of the main scale. Then what happens? The zero error is said to be negative. Sorry, this is not positive. This is said to be negative. If it is on the left hand side, this is negative. Okay, so it is equal to the distance between the coinciding vernier scale division and the total number of divisions on the vernier scale. Distance between the coinciding vernier scale division, coinciding the vernier scale division and the total number of divisions of the vernier scale multiplied by the least count. So what will be the negative zero error? See, This is the negative zero errors. This is the main scale division, and this is the vernier scale division. So vernier scale division is on the left hand side of the zero of the main scale division. Okay. So this time what do we see? The 8th mark of the vernier scale is coinciding with the 8th mark of the main scale division. Now, how to find the negative zero error? This coinciding division, that is 8th mark, 8th division, is we need to find out the difference between the 8th mark division and the distance between the 8th division and total number of divisions is 10. So 10 minus 8. Okay, that gives us 2. And that is multiplied by the least count of this one. I'm sorry. Negative zero, to find the negative zero error. Okay. So to find this error, the division of the vernier scale is noted, that is coinciding with the division of the main scale. Then the number of the vernier division is subtracted from the total number of divisions of the vernier scale, and then the difference is multiplied by the least count of the vernier, which gives us the negative zero error. If the least count is 0.01 and the 6th division of the vernier scale coinciding with the main scale, then what do we do? The total number of vernier scale divisions are 10. So zero error will be minus, that is, as it is negative, so it is taken to be minus. So minus 10 minus 6, that is equal to minus 4. That minus 4 is multiplied with the least count, that is equal to 0.01, and that gives us minus 0.04 centimeter. Now, what do we do with this negative zero error or positive zero error? What do we do? We, for making the correct measurement, we first, what do we do? The correction which is caused due to the zero error, what is this? That correct measurement with the vernier calipers having a zero error with this proper sign is done by subtracting from the observed reading. What we read from the vernier calipers, the observed reading, from that reading, we subtract the zero error with the sign. Okay, so what happens if the zero error is positive? If it is positive, then observed reading minus the positive reading, positive error. Okay, that means we subtract the positive error from the observed reading to get the correct reading. And if the reading is a negative zero error, then what do? We take the observed reading minus the negative zero error. That means minus and minus negative zero error. That means it becomes positive zero. Minus into minus, that becomes positive. So observed reading plus the negative zero error. Zero error, not negative zero error. Here it is zero error, and we have made it minus minus positive. Okay, so that means what do we do? For negative zero error, we add to the observed reading. We add the zero error to the observed reading. Okay, so positive zero error, we subtract the zero error from the observed reading. For negative zero error, we add the zero error to the observed reading to get the correct reading. Okay, so this much is for today. I have completed the vernier calipers. Next, I will start with the screw gauge, and then is the simple pendulum is left. After that, I'll discuss the question answers. So please go through this. If you have any doubt, please write in the comment box. You can also refer to my email ID, kasturi74@gmail.com. And then please press the like button if you're liking the videos. Share with your friends and colleagues so that they can also be benefited from these videos. And the last thing, but not the least, that you need to subscribe my channel to stay tuned with me, and also press the notification bell so that you can get the notification of my next video. And I'll be discussing after this, finishing this chapter, some ICSE pattern question answers, practice questions, and then I'll discuss the some other questions which are related to this chapter. Okay, so go through this videos, all the videos, And one more thing I'm telling you from the last few days, that please meditate before starting your studies for the day. Okay, that will help you in recalling the subject which you have studied. That will increase your concentration power. Okay, so thank you for watching and have a good day.